system. Then you've got nerves. These are nerve cells. They look like this, and they connected to a whole lot of other nerve cells. Yeah, there's a whole network of these things. Well, when they are getting the microvolts from the other nerve cells, when it starts to fire, it goes with electricity. Then this nerve cell will gather this electricity and bring it to the following one. But there's a kind of a
distribution.
There's a long sheath there that's called an axon, and the electricity is guided there and jumps over these parts which are actually shielded with other cells, and then it goes to the synapse. This is called the synapse. And if I make a bigger part of the synapse, there are neurotransmitters in little vesicles here. The neurotransmitters like dopamine and acetylcholine, serotonin, and GABA. And GABA is short for gamma aminobutyric acid. These are quieting the brain down. These are activating the brain. Well, if this is the following nerve cell, there are kind of docking stations here. We call them receptor sites. And these neurotransmitters, when the microvolts come in here, these little vesicles burst open and come into the receptor sites. And they sit here. And this happens with these as well. And if there are more neurotransmitters which actually slow down, then it will be slowed down. So then this impulse will not be carried on to the next. But if there are more activators than neurotransmitters that slow down, then the impulse will be given through to the next cell, and then it will start firing through the whole network. So this is like the gas pedal and the brake. Yeah? If there's too much of the gas pedal, then people get into panic attacks, and then they can't stop, they can't contain their brain, and they get nervous and they get frightened, and because then they can't stop themselves. It just goes firing on and on and on and on and on. If you have too much of those very slow things, then you're lethargic, you can't get out of your, and there's no energy there. Yeah. So then too much is actually slowed down. This is how it works in very simple terms. Yeah.
I got it.
So what you are actually doing with this is that you're making a better combination between the slow and the fast waves.
Right. So
yeah. And serotonin,
you're balancing in a way.
This is balancing, yeah. You need a certain amount of energy, but on the other hand, the energy shouldn't be too much because you can't contain it. Yeah. So you need a balance between this, and then I will straight away go to what comes out of our. I'll get something like this. Yeah. If we start with with your assessment, what we just did in the beginning, yeah. So this was the basic measurement. I've got all the microvolts as a function of time here and on all the locations. So these are 19 locations. Effects. You said like yours is quite okay, but sometimes you have a lot of artifacts like there's movement or something like this. This is actually quite clean EEG. But you also see that some of them is a little bit more intense than others. What we do is we use all these data and we make a kind of a general spectrum out of it to see how much the energy in the brain is distributed about the frequencies. So that's something like this. Here we have the microvolts, and here we have the frequency with which a neuron is firing. Yeah, so the
impulse of energy, how fast it goes.
Yes, and it goes from 1 to something like 50 hertz, so 50 times per second. Then you have slow waves and you have fast waves. And every location has a kind of reference curve, something like this. And every location is also, the reference curve is also dependent on age. So with every age group we have a different reference curve. Yeah. So just say this would be a reference curve for one of the places, one of the locations.
Yeah.
Then we also have an idea what the standard deviation is from that. So if normal people, they are in between these two brackets. Yeah? Well, the slow frequencies, we have 3 different frequency bands in those slow frequencies. The first frequency means that from 0 to 4 Hertz is delta. Yeah, this is delta. This is a frequency band that is very slow waves. They fire 0 to 5 times per second. Yeah? Theta is a little bit higher, it's 4 to 8 times per second. Alpha is 8 to 12 times per second. Well, this whole part, these 3, delta, theta, alpha, these are all very important for the stability of the brain. And that means it's like if you have a sailing boat, it's your keel. Yeah. Then we have a specific frequency band which is called beta 1. And this gives you balance in your autonomic nervous system. This is very important for stress resistance. So this gives you resilience. This is what is important for people to be able to be stable in life. That is, if there's some stress, okay, it can just absorb it, no problem. Well, then we have 2 other frequency bands. This is beta 2 and beta 3. These are higher frequencies of up to from 15 to 22, from 22 to 32 Hertz. This is what you need for cognition. This everything you learn and do or in action, you need that. The important part in your case, this is interesting, is our alpha peak. There's a kind of a peak here.
Mm-hmm.
We call that the alpha peak. This peak is one of the things that gives us relaxation. Sometimes it happens that your idling mode can be very, very, very high. And that happens sometimes with people that don't have a kind of sixth sense. It's a kind of a scanner, a radar. And then they have a high alpha, then they can scan. But if they learn how to use it and they can switch it on and off, then that's a talent. This is organized as far as the plan of your head. So here's your nose, there's the ears. So this is the frontal part of your brain, this is the central part of your brain, and this is the back of your brain. And this is the visual cortex, totally at the back of the brain. Mm-hmm. Now, if we just refer to looking at these curves,
yeah, that's good.
Yeah, so this is where you have actually, if we would compare your brain to the norm, yeah, and this is something, of course, I don't know. The physiology of your brain might not be the same of other people. So I'm just comparing it to what we know about a general brain.
Yeah. And
I'm not going to say this is too little or too much because I don't know. But we can just see the changes, because these changes, I will just show you the change to the very end of the sequence. This is when you had all the other things doing, and then the end one is this one. And you see that it's actually quite similar. Mm-hmm. Yeah, quite similar, except this one. And this part is the part of the emotional brain. And so you're doing emotional work. So it seems like while you were doing this, it ended up that you are releasing part of whatever was still there as emotional load. If the emotional, it comes up higher here, so it means that there's pressure there, and this is actually pressure from the amygdala, the central part of your brain.
Can you wait me a little second?
Can
I take this off?
Yeah, sure. Sorry. I'll clean you up
later. Yeah.
Okay, so there's been a difference from the beginning to the end. There's been a difference in the emotional pressure of your brain. It seems that your brain is releasing it after the exercise you did. Yeah. But let's see how it went along. Okay, I take this one again. So this is the starting out.
Mhm.
Then with eyes open, this is the red one. And then you see, of course, the alpha peak goes down. We knew that.
Because it's
Yeah.
in action.
Yeah, because you open your eyes and then all those, the freewheeling and idling mode neurons are going down. So this is what we expected. So that's fine. So we're not going to deal with that anymore. The very first thing you did, you went into that kind of a quiet meditation.
Yeah, yeah.
Well, nothing much happened there. Yeah?
Perfect.
This is moving a little bit. You see, this is the alpha's going up here.
Mm-hmm.
That's moving a little bit. That's actually, this part is moving the most of everything. You see that this is also, the alpha is moving up here a little bit,
Mm-hmm.
making it more equal to the other side, which is always a good sign. You always want to have left and right more or less the same. So that's a good sign too. Okay. Then that's the second part of that meditation.
The fast breathing. The second part of the.
Of the quiet one.
Yeah.
And then we have to actually see what the difference was between the first and the second. So this was the first part and this is the second part. You see everywhere your alpha's going down. It seems that with that kind of meditation, you actually are putting your brain to work again. Yeah. So that part is going down. The relaxation went back to, say, going back to work.
Mm-hmm.
Yeah, which is probable. Okay. Then you went into the fast breathing.
Mm-hmm.
And what are we seeing here? We're seeing here this huge thing coming up, which is also much more alpha than you had before. And that's quite remarkable because you already had your eyes closed. So you are actually reaching out into this other realm. And this is also reacting quite a lot, this part.
Mm-hmm.
Now, the emotional places are these places.
All right.
And these. So this is acting up enormously, but this is something that is happening, and I haven't seen that happen from the one moment to the other like this before. So this is new for me. This is extremely important. So we'll have to find out what is really going on here. Your frontal lobes are activating. Yeah, because these are going up here. You're getting more fast frequencies. Yeah? Because this is the same as like this line. So the beta 2 and 3 is going up here. And so your brain is working hard actually. This is the first part. The second part, that is the
When I stop breathing or something?
No, this is the second part of that fast breathing.
Yeah, fantastic.
Yeah, the second part of the fast breathing. Then you see this already starts to go down again.
Mm-hmm.
This already starts to go down again. This starts to go down again and then normalizes again.
Mm-hmm.
And then this part is doing a little bit of a different thing. It's reacting reverse. You see the second part is more active here and then, but why? I don't know. Okay, then we went over to, then I'll go back to the very first one and then I look at the prayer. Look what happens with the prayer. Quite amazing. Part of it is muscle tension, but part of it is also here your alpha goes up really high. You see? And before you had actually quite a lot of lack of energy here, but the energy here is really huge, high, extremely high. But part of it is muscle, so I don't know which part is muscle and which part is your brain.
Yeah.
But you look, this is your
emotional.
But also your the muscles of your jaw here. Yeah. So also here I can't say which is what. But this is the fact that the alpha goes up. That has nothing to do with muscles, because muscles is just for past 20 hertz here. This is muscle here.
All right. Yeah.
But this part is not muscle. So this part is definitely changing with your prayer, and this is enormous. You know, I've been measuring people with meditation, but this big change in meditation I haven't even seen before. Okay, let's see what goes on then. You had your prayer, and then after that you did this other thing.
Reprogramming the memory?
Yes, reprogramming memory. And that's also, then you see this happening. You see this part is then moving very, very highly. your frontal lobes are working hard. And it's quite especially this part here, you see? The frontal lobes, but also this part here, this emotional part is working a lot. But also this harmonic is coming up again. The harmonic that you had also with the very first part of that breathing.
Mm-hmm.
So it works along more or less the same lines. And then the second part is the orange one. Then you see a lot of muscles coming in again. You see this? The first one was quite quiet, but the second one, the orange one, there's a lot of muscle tension again. And then again, I don't know what is muscle tension or what is the rest. And if you would compare the orange one with the prayer, then they look a lot alike. So it looks like that, as far as your brainwaves is concerned, that the prayer looks a lot like that emotional reprogramming that you've been doing. As far as your brain is concerned, of the influence that your brain that has on your brain, or maybe the realms that you tap into with your brain. I can't say, but the thing is, the fact that the alpha goes up so much, that's really relevant. Anybody can say this is all muscle tension, which probably part of it is true. But this is definitely different. And then, if we just want to go back again and see what happens when you're doing nothing again, back to normal. So this is quite remarkable that the prayer and that memory reprogramming, that is quite amazing. Yeah. And now we're going to look at something else. This is how energy is distributed in your brain. Yeah. This is eyes closed and eyes open. Then we keep the reference eyes closed. This is actually the first part, does not happen very much. This is the second part. This is the breathing, first part of the breathing, and second part of the breathing. Then we have the prayer. And then we have the two parts of the memory reprogramming. Okay. Besides this, we look at something else. We look at, if you have the brain here with all the locations that we've been measuring, we look at how this one communicates with that one, and communicates with that one, and communicates with that one, and communicates with that one. And then, not only this one, of course, but all the ones with each other. And we do that for every frequency band.
Perfect.
Yeah? Okay, now we're going to go through those in very quickly, just to see how, let me see, spectrum, view. We call those coherence maps. Now we're looking in the delta band now, yeah? And then this is a plan of your head again, with there your nose and your ears here. And the way to look at this, just for instance, we look at the place in the middle of your head. In the middle of your head you have another plane. And here we have the middle of your head. If you look at this in the delta band with your eyes closed, we see that the communication is normal when it's green in this area, but towards the frontal part it's less than we expect, and at the back it's more than we expect. If you look at communication, when it's blue, it's just like this. The telephone doesn't get any answer, and at the back, when it's red, there's the busy tone. You can't get in. It's just telephones going all the time. Yeah. And you see, in your case, you will find a little bit too little communication of your frontal lobes. This is with the eyes closed. Yes. The back of the brain is more or less okay. if we go on to the same delta band with your eyes open, it's more or less the same. And then with the very first thing we were doing, that was the silent communication.
Silent meditation.
Silent meditation, getting better. You see that in the second part it's getting better. Okay, then you're doing the breathing. It's changing. It's getting much better. This part is the only thing actually that's still a little bit of this, but it's getting much better with the breathing. This is the second part of the breathing. Again, getting better. And then we go on to that memory recall, and boing, very different.
So this means
a totally different thing happening there.
there is communication a lot, and just a little blue dot without communication.
Yeah, but this is actually, there's so much happening there that there's over communication. So the whole system just is getting blocked actually. But yeah, you're doing something special there. So I'm just seeing that it's different. Okay.
Yeah.
The other one I just didn't. And then with the other part also still is there. That was the last part of that what we were doing.
Memory reprogramming.
Yeah. And then this is the. We go back to normal again. So there's a lot of things are changing and happening in that brain. This is a dynamic thing. This is just neurons, just a whole bunch of neurons firing with each other, and you're looking at the result of that. But it is very, very different. And I'll just show you the highest frequency band. So like here, is it like the beta 3? If we're in the beta 3, beforehand, I'll just go back to the very first time. Okay, that was pretty much perfect. Eyes closed, perfect. Yeah. Eyes open, actually also perfect, all green. Then we go to the first part. Now it's getting a little bit more busy there, but there's still no problem at all. That still stays the same. That's fine. Here a little bit of change there, but not too much. Also fine, no problem. And then all of a sudden, with the prayer, this happens.
That means that the back part of my head is communicating with the front part?
No, it's just that there's so much communication, and this is, it doesn't mean that it's wrong, it's just that it's more than normal. Yeah, you're doing something special, and we see, this is what happens. And of course, you come back to normally again, but there's a lot of things happening there, and then it quiets down again afterwards, yeah? So don't say that it's wrong, but it's just very different. And this is still happening at the nearly the last part, and this is quieting down again, so you're coming back to normal again. See? So in every frequency band we can see those things happening. Now I'll give you one more. This is the alpha, that's the interesting one. And we know from alpha already in the beginning, this is eyes closed when you started out. So also these frontal lobes are a little bit getting not enough communication. Okay, eyes open, more or less the same thing. And then we go for the first thing. And this is this alpha increasing, you know? And when you reach out to the scanner or this radar, it gets what we call hypercoherent. It gets like this. So this is actually the proof. That's actually what you're doing. Yeah, it's not wrong. It's just that your brain is actually reaching out to another disk. Your computer is going to another disk, something like that. And then the second part was a little bit less, and then start up again, and then it's actually stayed that way. And this is the other one, and this is, and it still was a little bit like that when we did the last measurement. Yeah, so it's still, the radar is still going on, still scanning.
I can feel it, yeah.
Yeah.
Because I finished, but then I can feel that I am completely open to something that is not my. It's beyond the normal state. I reach other state. I feel that.
Yeah. So this is what we can see there. So these are the things that come out of this kind of research, and of course there's a lot more at the back of it. But the interesting thing to watch actually is how if I switch all of them on, just watch what your alpha does here. You see, it just goes in all those 10 measurements that we did with all those different states. It goes really up and down all that. And then you look at the back one as well. At the back of the brain it's even higher. It can go really high, and this dip is more or less the same. That's the same everywhere. This is also more or less the same everywhere. And this part can move up quite a lot. And this area here on your sensory motor cortex, that moves up and down quite a lot. So I would say that your brain is compensating around this point. I don't know if anything really, if you had some injury there or something happened, but this is moving much more than the other side actually is. You see, this one's not moving as much as this one is. But this is also the intuitive part of the brain, so that might be more active with you anyway. And this part, this is with your the emotional part. Now that's moving up and down very much as well. Well, I just want to show you one example of someone else with post-traumatic stress, because your interest was there. This is the same picture that we're doing here with you, with someone with post-traumatic stress. The red line was the very first measurement we did with him.
Mm-hmm.
And then he started training with us, and within 4 weeks it was the green line. So this came down to here,
mm-hmm.
and this came down there, and that was just a general state of his, you see? So that remained like that. Yeah, your brain changes while you're doing all kinds of things, but usually it doesn't change at all.
Returns to the natural state after.
Yeah, but usually it doesn't change this fast at all.